So yeah, we will be doing dynamic programming, but I will not be showing any video that might get me a copyright strike and my channel can go down. I don't know if it's that if that's true, but yeah, I can get copyright. So I'm going to see Vivek Gupta's lecture and I'm gonna continue it. And it was scheduled for 8 p.m., but why hasn't it started like on June 7th? Okay, so yeah, just as soon as
And my fundamental
yeah, and I'll be doing it. I was doing it in my tab and then I was explaining it, but I think I did want to make notes of it. So I won't be like I won't be making uh, same video on my tab and making not making and making notes on my laptop. That doesn't make any sense. Dynamic programming. Yep. So yeah, what was taught till I'll just have a recap. It's good. And I have 30 minutes before I sleep, and I think I'll sleep today at 12. So yeah, what is dynamic programming? Uh, so here he has written that dynamic programming is nothing but a glorified recursion with caching. Okay. So yeah, last time I told like how Fibonacci and how when we use dynamic programming, the recursion tree converts to a directed acyclic graph. So yeah, that's how it gets converted. And uh, the recursion to stop it needs to has a base case, right? Like he also told the formula for fact Fibonacci, NCR, right? He also told like how dynamic programming help us to convert. Yeah, right. Okay, so there are two key properties for using dynamic programming. Like there are various questions like n queens problem. So there you cannot use dynamic programming to solve because there is no substructure to substructure or sub problem to solve. Like there are no overlapping sub problems and there is no optimal substructure, right? So if they like, for example, in n queens, there is uh, a row of n boxes, right? N into n squares. So you have row of n boxes, and n you can keep queen in any one of them. There is no optimal substructure that you should keep queen on a particular block. Like you get it right. So yeah, there is no such thing. So to find optimal substructure, so to use dynamic programming, we should have two things at first. Two key properties for DP for dynamic programming. is that first it should have an optimal substructure, optimal substructure, and second, it should have overlapping subproblems. What does overlapping subproblems mean? That all of, like in Fibonacci, whole sequence turns down to zero, like Fibonacci of 0 and Fibonacci of 1. And like it gets overlap, like you will, for calculating Fibonacci of 4, you will have to calculate Fibonacci of 2. For calculating Fibonacci of 10, you will have to calculate Fibonacci of 5, was like all of the numbers before it, right? And for calculating 10 and 9, you will need 8. So like this, there is overlapping subproblems. Like for 9 also you need 8 and for 10 also you need 8. So that is overlapping subproblems. Okay. So yeah. Okay. So that's what you taught. And then later, educate. Okay. So there are two ways of calculating DP. What is DP? I don't know. Like how to calculate DP. DP is a method, right? Two ways of, I think, solving DP would have been a better name for it, but he is the king, like he is the writer, so all things will happen according to him. We don't have a say in it. So, two ways of solving DP, solving dynamic programming. First is top-down approach, and second is bottoms-up approach. So, what happens in top-down approach? In top-down approach, uh, you will have to go from 10 to the base case. And in bottoms up, like you know that you have to go to 10, so you should start calculating from 0 and 1. Like that's what happens in bottoms up. And what happens in top down is like you're going for 10, then you ask for 8 and 9, then you ask for uh, like numbers before them, right? So that's what happened in top down approach. So here he suggests, like, for beginners we should always opt for top down approach. Like which one is better? He asks here, like which one is better. So better is nothing. It depends on question to question, right?
This is the difference between bottom up and top down. This is bottom up में पूरा भर रहे हैं. Top down we are going back and on demand. Top down is what we will focus on a little bit. Yes, but top down will only take as much space as the size of the memo, no? Because क्या मुझे उतना ही वैल्यू सेव नहीं करना है? That many states are there only, no?
And then what happens in bottoms up?
ठीक है. So this was the phase part one where I wanted to talk about uh,
So here he has shown the slide which says, like, Vivek, this all is too simple for me. Show me how to solve. That's what I'm asking. Please just don't kick me off. I'll just come and like fill and come up. I'll just come after filling. I'll just come after filling my bottle. So yeah, Vivek Bhaiya was just telling that this is all simple for me. Show me how to solve.
Basic recursion DP के कुछ terms, right? But I think very little value is built on theory, examples, ये सब चीजों पे. The real learning happens when you learn how to solve a problem. ठीक है भाई, विवेक सिखाओ मेरे को how to solve a new question, how to think about DP, because everybody will say कि okay DP ये है वो है, but the true thing that you need to learn is how to think on a DP problem from first principles is what we will learn today. Okay? And I'll show you a very interesting problem and I'll try to deep dive on that. And you might have seen problems like knapsack, coin chain, all of these will become easy with just one problem. Okay? And I'll teach you how to design solutions, not memorize solutions of DP, which I think most people do at the end of the day. Okay.
Okay.
Chalo, next, let's move to the next part. Before that, I think this is a good point if to maybe I'll see if I can actually get this. Why isn't it not getting wasted? I wanted to show something. 3, 2, 1. Is DB possible in C language? Yes, it is possible. Is DB possible in C language? Yes, it is possible. It doesn't need, it just needs basic recursion. Next, I'll teach you the most interesting part, which is how to design solutions. And I think you'll enjoy it. Basically, framework of how to think about DP.
What is this?
Types of DP, that. Everything is same, it's just different forms that you have to know. But before that, you need to know how to design solutions of DP. That's what I'll teach next. Okay. That's possible. Actually, get this. Why is it not getting listed? I wanted to show something. But weirdly enough, it's not. Let me just quickly do one thing. Why is this taking so much time? The QR code you guys are waiting for. Is DB possible in C language? Yes, it is possible. It doesn't need, it just needs basic recursion.
What is this QR?
Next, I'll teach you the most interesting part, which is how to design solutions. And I think you'll enjoy it. Basically, framework of how to think about DP. Types of DP, that. Everything is same, it's just different forms that you have to know. But before that, you need to know how to design solutions of DP. That's what I'll teach next. Okay. Scan this QR code real quick for attendance. Okay. So I'll give you guys quick 2 minutes break. So that we can discuss, take questions. Types of DP, if you have any questions and stuff, please increase speed. Yes, we'll do that. Don't worry. If I come to speed, then most of you guys will fail to keep getting forms. Why do we need forms? Because you want to be able to solve questions faster. That's why. So we'll talk about framework, which is how to think about DP problems when you see them, and forms is like what different types of DP problems. Like you might have heard about, right? Knapsack problem, double DP, things like this, bitmask DP. You might have heard about these things. Okay. Anyway, don't worry. अभी तो start करें. Why are you guys so worried कि वे होगा कि नहीं होगा? सब करेंगे. तो start करें. Any other questions that you guys have for me? Quick 2 more minutes, then we'll start. It comes with the handle AC later. Okay. If you want to find me on, so I no longer compete. I mostly teach now. So I'm more in the coach mode now. Okay. So that's a different life altogether. I understand top down and bottom one. करके top down में बनाएंगे solution, then you'll understand. Number only for girls, किसी के लिए नहीं. Don't worry. कमी नहीं ज़्यादा. Yes, coach mode. Yeah, obviously I'm master, so I can easily national master, so I can easily use coach mode. Yes, coach doesn't play competition. I don't participate now, but I often take, like on YouTube, I take discussions on LeetCode DT on certain interesting ideas, and that's what you can also join if you want. Right? Sorry, हो जाए. यही करना है. What is code forces profile? You will get the descriptions of all these things as you go through the camp. Okay. DP workshop. So the camp is basically multiple instructors taking different classes. So this is like my class, and there will be more people taking next classes and stuff. DP workshop was on YouTube. It's like I took it 2 years back. For those who are asking, I took it 2 years back. That content will still be relevant. You guys can watch that to improve further. Like different forms that I'm going to talk about a little bit. What is CF profile? Things are for class entries, please. Let's see. Okay. Quick problem in your screen. Okay. You guys can see the problem now on your screen and the link to the URL to the form also if you want to write that. But I think you want me to copy it from screen. It's super hard. Attendance मिल जाएगा, don't worry. I'll give you that at the end also. जिसको attendance लिखना था करके चले जाओ. I don't want them in my class. Next, जिनको पढ़ने आना है next. ठीक है. अब ऐसे ही सिखा दो लोगों को. Right. Choose to do that. Okay. I'll teach you a framework which will make your DP almost next to perfect. How to do that way. Yeah, use G.
एक framework बता रहे सर जिससे
पढ़ाई पे ध्यान दो सब. Yes. चलो next. अब move करते हैं. Fractional knapsack भाई नाम से कुछ नहीं होने वाला. There is no name required. Okay. नाम कम याद करो, काम ज्यादा याद करो, ठीक है? How to actually solve problems is super important. Read the problem carefully and try to think
10
about
items,
how
each
to
item can
design
be
solutions.
taken only once. Can you take
So basically, this is saying that there are n items in front of you. Each item has a weight WI and a PI profit. Okay, this is a very standard. There is a problem called knapsack. Okay, but I have modified it. Number one is you have a big bag of weight. You can take at most capital W weights. The sum of weights of item that you pick has to be less than equal to capital W, and the number of items that you take has to be less than equal to K. Okay, you have to maximize the sum of profits of items taken. You have to maximize the sum of items profit of items taken. Okay, how will you decide which items to take and which items to drop?
what?
20% question clear, कुछ कुछ समझ में आ रहा है what we are trying to do. Let's take
Oh, ठीक है. Love. प्रेम मत देना please.
an example. Let's take an example. Some items to take and which items to drop. 20% question clear, कुछ कुछ समझ में आ रहा है what we are trying to do. Let's take an example. Let's take an example. I think that would be making it much more clearer. So let's say some items are there, like one with a profit of 3, an item with weight 5 with a profit of 2, and an item with weight 2 with a profit of 5. Okay, and you have a bag which has total weight 6. Which items should you pick in the bag so that you don't exceed the sum of, these are the weights, these are the profits. So one way is you pick this item and this item. So if you take these two items, the sum of weights is 6, so it's less than equal to 6. That's fine, that is given to you. And the value of K is 2. You can at most take 2 items. So you will take this item and this item. So in this case, the weight is matching, and the sum of profits is 3 plus 2, which is 5. But I think you can do better by dropping off this and actually taking this one, because now the sum of weight is still 1 plus 2, which is 3, which is less than equal to 6. Number of items is still 2. You have not exceeded the limit, which is K equal to 2. And then 3 plus 5 is 8, which is the maximum profit you can draw with taking 2 items and having weight less than 6. Okay, so you want to be making sure that you don't exceed your weight limit, the capital W given in the problem. Okay, you don't want like the number of items to exceed a given K in the problem, and you want items that you pick has maximum sum of profits possible. Is the question clear to everyone? Quick +1 in the chat. This is the question. Now you can read it again, and I think it will make much more sense. No, only once. Matlab, either you will take it fully or not. Exactly once. Okay, either you will take it as a whole, the whole W, or not. Okay, there's no fractional and stuff. Okay. I'm not taking a theory class. You will learn this in your college. Fractional knapsack, we'll learn to design solutions, not to go through history and Thomson model, Bose model, Rutherford model. See that technique सिखाओ. Constraints. Let's say open constraints for now. If you want the constraints, let's say everything is still it's open constraints. Let's say 100. Everything is still 100. Okay, your weight is still 1000. All the weights are till 1000. Constraints is not important. Okay.
Question.
Now I can guess already that people will start throwing names on the chat. Ki bhai, cadence algorithms, brute force, recursion. Okay. Is that what you do when you see a problem? When you see a problem, what do you do at the start? कैसे सोचते हो? Like, how do you even think about solving a problem? ये problem देखा. What do you think?
क्या सोचा? मैंने क्या सोचा इस प्रॉब्लम को देखने के बाद?
Maybe some idea is there, like maybe greedily trying some profits might work, which will not work in this case. Like maybe it might work over here, but if I swap these two values, maybe it might not work. Right? If you just swap these two values, if you try to pick the items which has the highest profit, you will pick this, and then like let's make this 5. Okay, weight is equal to 5 and k is equal to 2, and then you cannot pick anything, but rather a better way would be to pick these two, so get a better profit. So
Yeah.
greedily trying to pick the maximum profit will might not work.
Yeah.
One more thing that people think when you see the problem, see, today you don't want to learn कि विवेक इसका solution क्या होता है. Try to understand मैं सोचूं कैसे. If you can understand that one thing, you will be growing very very fast. Listen to me very very carefully. No, sorting will not work. Okay, I'm not trying to give you anti-test cases for all ideas. It will not work. We are trying to go in the direction of recursion. How to design a solution that will recursively work for this problem. Okay, but Vivek, how do I think about such a problem? First of all, okay, I think one of the problematic things that people do at the start. I'll just quickly. Why is this? Why did the board crash? Super weird. I'll just quickly get it up again. Really? I think something crashed. Let's go back. Okay. Generating all possibilities. Yeah, that is obviously an option, which is brute force, but we want to do it faster than brute force now. So how do you think about a problem when you are thrown at DP? Okay. Because case by case, pick or not pick a memorization to optimize it. Knapsack style, just save the key item that might do. How will you do that? Check. So when you think of a DP problem, right, what I'll give you guys an advice is try to read the terms very, very carefully and try to design the solution in steps. First thing, you are trying to build a solution, right? Out of these items, you will take certain items and stuff. What are you building? Are you building a subarray, a subsequence, or a subset? Choose out of the three.
Subarray, subsequence, or subset. What are we building?
Are you choosing a subarray, a subsequence, or a subset of the items given? You can say subsequence also, because in an array, subsequence and subsets are almost the same. It's like taking or not taking certain things. So, but I'll say subset, right? You're dealing with subset to some degree, because order doesn't matter. Just the profits and stuff matter, right? Because individual items, weights and stuff matters, but their ordering don't matter. So subsequence means order matters. Subset means order doesn't matter. So first thing that you realize when you're dealing with any problem is,
and subsequence means order matters, and subset doesn't mean subset means that order doesn't matter.
Number one, subset, subsequence, subarray. Tick one. Most of the times you will have one of these. I'll tick subset, right? Because you're dealing with subset. Second thing is it a counting problem or an optimization problem?
It's a counting problem.
No, counting problem or an optimization problem?
Second thing.
Bad handwriting. I'll improve. Optimize. I'm not a doctor, right? So I should be better. Chalo. Optimization or counting? What we are dealing with right now, are we trying to count all possible ways to build this? No, we are trying to maximize. Whenever the terms are maximize or minimize, we are dealing with optimization. What we are dealing with right now, are we trying to count all possible ways to build this? No, we are trying to maximize. Whenever the terms are maximize or minimize, we are dealing with optimization. Okay? Whenever you have to minimize or maximize certain process or certain choices, you are dealing with minimization or maximization wala problems. This is a optimization problem. Counting means count the number of ways in which you can make certain profit or something like that. Okay. Count the number of ways you can place n queens. Count the number of ways you can select a subarray. Things like this. Right? They are counting problems. This is an optimization problem. Okay. Fine. So now you know that what kind of problem you are dealing with. Next in DP, what you try to understand is what is this subset. So you start thinking in terms of a specific idea, right? That you need to see, like knapsack or stuff, but what I call as form one, let's say,
okay,
is one. What you try to think about is you have bunch of items, right? W1, P1, W2, P2, Wn, Pn, right? To build a subset. How do you get there? For every item, you have a choice that whether to take it or not take it, whether to take it or not take it, right? That's essentially how you build subsets, right?
Right.
Yes or no? Is this how you build a subset? For every item, you have a choice of take it or not take it. In fact, 2 to the power
In form one, like you have to build a subset and maximize the profit, right? So whether on every object you will have to see, like you will have to take the element or you don't have to take the element.
n number of subsets comes from here only, right? Every item has two choices, so 2 to the power n number of subsets,
Subsets.
right? So we are dealing with this problem where you have options for every item, whether you have to take
Options.
it or not take it. Okay, this is essentially the setup. You want to be able to find the optimal setup, optimal choices for all the items. That's what we are trying to do, right?
Yes.
That's what we are trying to do. Okay, great. Form one, we have a collection of items. We want to take certain subset out of it. Every item has a choice to take it or not take it, but we want to do it optimally. Next thing that you try to think of is, why is everything not feasible? What is restricting you to be doing all 2 to the power n tries? One is obviously like complexity will not pass, right? The second is, why is every subset not feasible?
Every
Is it
subset
because of
will not be
these
feasible because of the
two
constraints.
constraints here?
Yeah.
It's not
To the power
constraint of the
n
values, it's
options.
the constraint on subsets, that whether it's feasible or not, right? Whether it's allowed or not, right? Are the two that is making our life hard? I mean, or else we could have just taken every item that was positive profit, take it into our account, and we would have gotten a profitable like set, right? But just because
Correct.
of these two restrictions, it's becoming harder, right?
Constraints.
So this constraint is what is making our life hard, right? Yes or no? Clear till this point?
Unreasonable.
This is just initial observations and notes that you are kind of building on a problem. People say, no, observation, quote unquote. This is what you observe in a DP problem, that it might be a DP problem. You have a subset to be built and you have to optimize certain things. You have this setup of form one where every item has a taken or not taken. And not, why not everything is feasible? Because you have two restrictions. If you can do this for any problem, almost every problem is solvable. Next steps
Okay.
are mechanical, which is just doing the same thing again and again. Vivek, what is that? Teach me that, right? That's what that is what I call as framework. Okay, that how to next technically just convert this to a solution, right? So what will be my framework for solving a DP problem?
Framework क्या होगा?
You have a setup that every item can be taken or not taken. That is your form one. So next step one will be do these observations. Ki it's a
Step
subset being
one.
built. You for
Ideal.
every item you're taking taken or not taken, right? And you are building this particular setup. Like that. This is what you have to do. You are recognizing the
Use
restrictions and stuff. So you basically
definitions.
this is what I call as recognize the form. Okay, recognize form. Okay, and this is basically this form. Take, not take, take, not take, and you have to build a subset. Very, very simple to recognize. Everybody was able to do step one. ये तो बहुत simple है. Everybody can understand this. Quick plus one. We'll do step by step. And any problem can be thrown in the same steps. First, recognize form. This is form one problem, which means you are dealing with bunch of items.
Form one.
You have to build a subset. Every item has
Build a
take, not
subset.
take choice. This is clear to everyone, first of all. Okay. Great. Next, step two, design the DP recurrence. Design
Take or not
recurrence.
take.
Okay.
Form. Right.
Yeah.
Each element will have take or not
So
take.
there are 5 fundamental forms, few advanced forms that you learn with practice, but
Step two.
every form will have the same steps going forward. Okay.
will have
So design
each
recurrence.
element
How do we
recurrence.
design? See, I'll teach you a very interesting way in which will make your life super simple. So we will write DP. Okay. Over here. This is what people find super hard. Vivek, how will I write the recurrences? How will I know the recursion में I, J, K लगेगा, क्या लगेगा? People make it super hard, whereas it's super simple. ठीक है? Firstly, you need a process to generate all subsets. One way to do that is go to a particular item and decide to take it or not take it. Based on that item choice, you will go to the next item. So you are basically branching off. Hey, I have my current item and I have a choice that can I take this or not take it? Take it. Okay, then next item choice. So over here you can take, or you can do this take, not take, take, right? So you can decide this item and then rest of these items can be decided later, right?
Okay.
यहाँ तक समझ में आ रहा है? If you take or not take, depending on that, you can decide what to do later. इसके बाद.
Right.
यहाँ तक clear है? That depending on the choice, things will change forward, but you can decide here and then move to the next item. One by one, I can decide, and then eventually I will get a subset. This is a process to generate, right? So I will say dp of I. I means which item I am currently deciding to take or not take.
Okay.
First state. Is this part clear to everyone? Which item I am currently deciding, yes or not, take or not take. Is this part clear?
Decision item.
यहाँ तक clear? First state, for every item I have to decide. So let's say I am at the ith item and I'm deciding whether to take it or not take it.
Okay.
This is my first state. Okay. This comes from the form. Like every form one problem will have the same first state. ठीक है, जिसमें भी take not take वाला आएगा, knapsack, coin change, कुछ भी ले लो, it will have the same state. Okay. Next, what do we want to return from the DP? Every DP function wants to return something. Okay. What do you return? You want to return something that like that was asked in the problem. क्या पूछा गया था? Maximize sum of the profits.
Yeah.
Okay. What will we return? Maximum
Profit.
Sum of profits from items I till n. Because I am right now at I have already decided the previous items. तो उसका मुझे profit नहीं मिलेगा. I cannot get those profits at all. I am at the ith item, so I can decide to take it or not take it. And accordingly, I will get this and the future profits. So what is the maximum sum of profit, quote unquote, what was asked in the problem for items I to n? And this part, what to return, comes from what was asked in the problem. In 70 to 80% of the case problems that you will see. If you're dealing with interview problems, probably 95% of all problems will have the same return type of what was asked in the problem. Okay. Maximize sum of profits. So what we will do, we will return maximum sum of profits for the part of I till n. This is called optimal substructure. Optimal of 0 to n depends on optimal of I to n. Remember, there was a term called optimal substructure. You can make it from 0 to I also, it doesn't matter. You can do it that way also. I just write it this way.
Maximizing sum of.
यहाँ तक clear?
हाँ.
This is making sense. Quick +1. यहाँ तक अगर clear है तो I need +1 first because checkpoint करते करते चलते हैं धीरे-धीरे. Then only it will make sense. I want you all to be good at DP because DP is something that people fear. I don't know why. Maybe because it's a little harder, and it takes practice. But if you understand the core building block, right, it becomes super easy. So I'll explain the optimal substructure and all these things again a little later. Okay, don't go back to this. I just mentioned it once. I'll come back and explain it again. Okay, maximum ये जो items है from I till n -1 जो बचा कुछ item है, I am at ith item. From here till l, I have to decide which item to take or not take. For each item to take or not take, I will get certain profits. Jitna maximum बना सकते हो, I can get that. Okay. But now comes another restriction. कि भाई, can I take all items? No. So now tell me what helps me decide कि whether which items will I be able to take and which items will I not be able to take.
Which will follow the constraints you will take, which will not follow the constraints you won't take. Simple.
Let's say you have n items. You are at the ith item and you are deciding किसको लेना है नहीं लेना है. फिर इसको decide करोगे. फिर इसको decide. You will decide these items, right? So it
Yes.
depends on, first of all, capital W and capital K कितना restriction था, right? It depends on these restrictions.
Yes.
It also depends on how much you have already taken.
Yes.
Yes or no?
Yes. Of course.
It depends on how much you have already taken also.
Yes.
So I can try and keep it this way, that okay, maybe try keeping how much weight I have already taken and how much K I have already taken. You can keep it this way. Whatever will help you decide ki can you take it or not. To manage the restrictions, you try to put them in the state. This is how you design states. Okay? People find it hard to design states, what to keep in states. This is called states. The argument of the function is called states in DP. What is, how do you put these? Whatever will help you decide कि इस item को लेना है नहीं लेना है. Okay? Because if you know how much weight you have taken and you know the limit, which is by the way constant, like for a problem, you can decide कि अगर limit cross नहीं हो रहा, then I can take it. Clear everyone?
Yes.
Yes or no?
Yes.
How much weight I have taken, how much items I have taken. If I maintain that, I will be able to decide, no, can I take the next one or not? Because if it is in the permissible limits of the weight and if it's in the permissible limits of the number of items, then only I can take it. So
Yes.
these two states will help us manage the restrictions nicely.
Yes.
So this is called state designing. This is called design recurrence or state.
Set to design recurrence.
This will come from the form which you are dealing with, like subset. So go over every item and decide to take it or not take it. This part will come from restrictions, or sometimes it also comes from transitions, like the movement that you do, but mostly restrictions only. Okay. And the return types comes from what is asked in the problem.
So 2 to 3 things. First thing, this will which form? This will come from restrictions, and this will come, return statement will come from what was asked.
– 95% of your lead code problems is just this. Okay. Which form we are currently on, how much weight I have already taken, how much K I have already taken, tells me whether I can take the current item or not. And based on that, I will move forward. And this is how it should be.
Fine.
Right.
Right.
Is the step 2 50% clear to everyone? 50% I'm asking, I'm not asking for 100%.
Yes.
100% अगर हो जाता तो I would have been God and you also would have become God. 50% is clear to all of you or not?
Yes.
Yes. Great.
Yes.
Nice. So that's super good to see. Yeah? So many people interested in learning DP. Thought it's hard content. So this is weight taken and K taken. This is how you design this. Next step, step 3. Design transition.
Step 3, design transition.
Okay, design transition. How do you do that? Very, very simple.
Design.
Now, once you have the states, this step becomes easy. How? See, what is the picture in mind? You are having some number of items. You are at the ith item. This many items, out of these, the total weight that I have taken is this, and the item number of items I have taken is this. Okay, I am at the current item. For this, I have two choices. You are at the ith item. This many items, out of these, the total weight that I have taken is this, and the item number of items I have taken is this. Okay, I am at the current item. For this I have two
It would
choices:
be A
take
and B,
or not take.
take or not
Right, this
take.
is my setup at this point in time. Should it be W left, or are we maintaining W? Yeah, WK are global value, so we can do it that way. Actually lefts might be a little better, but not for today. I mean, I'm just
Yes,
teaching you how to design. ठीक है,
same
कुछ भी बनाना
understood.
सीखो. Don't be restricted on solutions that you read at one place. Fundamentally think ki, how can I design even something different? Why is something working, why is not?
Yes,
Because if you aren't at that level, you cannot really solve new problems on your own. You will only be memorizing solutions of वही 5 10 20 40 repeated problems that comes on lead code and think कि DP आ गया, but फिर नहीं होगा कुछ. That's what most of India is at this point in time. ठीक है कि 40 known lead code repeated problems जिसके videos YouTube पे होंगे, सबको वही समझ में आ रहा है कि वही solutions उसके रटे हुए हैं, but it's not that. Try to understand from first principles how to think.
ये फर्स्ट प्रिंसिपल्स होता क्या है भाई? Building block of true knowledge. First principle thinking is problem solving approach that involves breaking down of complex issues into the most basic components or first principles and then assembling them to create new solutions. This approach is often used in various fields including science, engineering, business and philosophy. Key characteristics: question assumption, basic components, reassembling. अच्छी बात, बहुत अच्छी बात. कि एक चीज को तोड़े कैसे और फिर उसको असेंबल कैसे करें, एक चीज को इतना बारीक तोड़ो कि वो समझ में आ जाए भाई, और फिर उसको असेंब शिट, दिस इज डायनामिक प्रोग्रामिंग.
Okay, please use a different color. Okay, it's a little less legible. Okay, okay. I'll not use red much. Okay, yellow is better. Yes, you can think it that way also then. So we will say dp of I have taken this much.
Okay,
I have taken this many items. How
okay.
many items I have taken? From here, what are my two choices?
So taken will be A and B.
Okay, take
I,
or
A,
not take.
B.
Okay, these are my two choices. Based on this, I will design my transitions.
Yeah.
If I take, which state will I reach? If I take it, I will naturally go to the next item, I plus 1. So I will go to this state, I plus 1. Okay. If I take this, how much weight have I
Take it.
taken? Whatever I had taken earlier, W taken
I plus 1
plus, I am writing it this way, W taken plus
plus weight of I
whatever was the weight of this ith item,
plus
W
1.
of I. This is the
You have
number of
not
weights, that
take
total weight that I have taken now.
DP
And how
I
much
plus
items have
1
I taken?
weight
The number of items I have taken earlier plus 1. Is this what is essentially the configuration that we are going into? Quick plus 1 if this is making sense. I know it might be getting a little harder slowly, but try to bear with me. The more it growth happens when your brain is trying to fight you कि भाई समझ में नहीं आ रहा है, but then you are trying to push it कि भाई समझो. That's when you grow. Okay.
मैं तो ऐसी,
Right? When you are at an ith item, you are deciding to take it or not take it.
yep.
So if you take it, the taken weight increases, number of item taken increases, right? If you are not taken, then in that case, you will go to this state, dp of I plus 1. I have not taken anything, so whatever weight I had taken earlier, that much weight only I'll have. K taken is this much,
Yes.
right? So this is basically the two configurations that you reach to. And if you take, you get a like reward. What were we calculating? Remember, go back to the definitions. Definition was saying maximum sum of profits from I to N. So this should give me profits from I to N. If I go not take, then I will not get any profit from ith item. But if I take, I will generate a profit of P of I.
Yes.
Right? If I take, I'll generate this. But if I don't take, I'll get plus 0 for this item.
Yes.
Right? Is this diagram making sense to everyone? This is in fact what you need to think in your mind to design transitions. And it's simple, no? Like naturally
You take
what
it, you will
जो
add
कर रहे हैं वही
profit.
कर रहे हैं. That's what we are doing,
हाँ.
no? जो track करना है, maintain that thing as we go forward, right? If you take it, you will get a profit of that item. If you don't take it, you will get zero profit of that item, right?
Yes.
By the way, guys, if you have not realized this, we are already done with the problem. Okay. So this is essentially the recursion. This is, if you have written this diagram, you will be done. One final piece is you need to merge these two solutions, right? At this point, I have both the options. Which one should I pick?
What options?
Which one should I pick over here? Max of them. Perfect. I should pick max of them.
Okay.
If I pick max of both, because whichever ones leads me to the better profit for the ith one, I will take that, no?
Yes.
Bus, this is the whole diagram. If you have built this and if you have this in your mind clearly, you are done with the problem. This is essentially all of DP. Simply designing the form, thinking of the form, designing the states based on what you need to design, which configuration you are in, how would you be able to manage the restrictions and stuff. Okay, and this is what you write as this. Okay, but this will be 2 to the power n. Yes, it's 2 to the power n. Coming to that, don't worry. I'll get you guys to the point where it is no longer 2 to the power n, right? Why max? Because I had to maximize my profit. तो अगर लेके profit जो मिला, नहीं लेके मिला, दोनों में से जो better, whichever one is better, I'll take that. If you take and whatever profit you get out of that, if you don't take whatever profit you get out of that, you want to take best out of both, no? You will take maximum out of both. जिसमें max मिलेगा वो ले लेंगे. That's being greedy at this point in time, but that's being greedy knowing the perfect information that if you take it, how much maximum you can generate. These DPs are giving you maximum with all possible future recursions, with all possible future choices. So if you have perfect information that if I take it, I will get this much, even if I do best. And if I take this, I'll get this much, even if I do the best. Why will not be greedy at that point, right? So this decision is greedy, given that you have perfect information over here, obviously, right? It feels like greedy, but it is greedy. Okay. So this is essentially the step 3. Step 4. What is step 4? Optimal substructures. Substructure to ho jayega. It gets managed automatically by this design of steps only. Where we are adding this P of I before taking max. Like this branch will give you Pi plus this much. We'll write the expression, don't worry. But before that, even before trying to write the code and stuff, there is a step 4. What should be the step 4? Do you know? TL check, time limit check. Okay. Bhai, will this code even pass? Nahi. Will this code even pass? भाई इतना लिख लिया, कोड लिखेंगे, पास नहीं करेगा, क्या फायदा होगा, है ना? So you should check whether this code will pass or not. Base case and stuff तो implementation details है, right? They will be get handled in implementation. Whether it will TLE or not, TLE check you can say, okay? Time limit check. How to do TL check? There is a simple formula. Number of states into 1 plus number of transition or average of the check you can say, okay?
There's a formula.
Time limit check. How to do TL check? There is a simple formula. Number of states into 1 plus number of transition or average
number of states into
transition is the complexity of your code.
1 plus average of transition.
O of this. This will be your formula.
Does it come from Master's theorem?
Number of states into 1 plus average number of transitions. This is a formula for you.
So
Vivek, what is number of states? Dekhte hain. I'll actually write. I'll zoom it out a little bit. Okay, this is the states that we designed. So I'll write it. I'll zoom back down in. I'll write it over here. DP of I, W taken. How much weight you have taken? K taken. Okay. What is the possible values of I? 0, 1 till up till n. N values, order n values. W taken 0 till up till capital W because you cannot go above the limit. Items taken 0 up till K.
0 to N.
These three things.
0 to W.
Is
0
this
to
what you
K.
need to get in every DP problem? States that what are the feasible ranges of the functions arguments that you're designing in DP? What are the ranges it can take? And this is n w k, so the number of states will be n into w into k. I mean, no need to add +1 and stuff. Order notation hai, so
Number
they
of
will get
states तो
reduced
इतने
anyways.
होंगे, ठीक है.
But is this making sense कि इतने सारे states हो सकते हैं? These are the number of feasible states that you can essentially
Yes,
reach to.
of course.
Quick
Like
+1. This is the
n
number of
into
states.
W into K. अगर तेरा
N
मतलब
number
बहुत
of
सारे
items,
weights
because
are
I was there in the first parameter. Weight can at most be W, so W. K is this.
at most, right? We have to take off them, right?
Okay. 1
Right
plus
states.
number of transitions. How many number of transitions are we doing for one particular state? For this, how much are we doing?
Transition 2. Like 2.
How many transitions?
Okay,
Quickly,
like,
give me in the chat.
okay. 2 transitions. I'll write it before.
Yeah, all the numbers. So that's why we are multiplying, no? All the numbers for all the n's for all the k's. So we are multiplying. 2. So this will be nothing but order n into k into w. Okay? This is constant. Order notation. It just suppresses
Number of
constants.
transition
So this is my complexity.
1 plus
If
2.
this will pass, we will code it. If not, then we'll not code it.
Of
Okay, that means we have to optimize
n
something further.
dot W
But this will pass, assuming that for this code, it is given in the problem ki n comma k comma w is up to, let's suppose, 100. So if you put 100 in this, 100 into 100 into 100 is 10 to the power 6. We know that in 1 second, 10 to the power 8 will
all
pass.
of
If you
them
put
are
formulas into that, that should be good enough. Ki n comma k comma w is up to, let's suppose, 100. So if you put 100
Now if there are total of 10 to power 2, 10 to power 2, 10 to power 2, 10 to power 6.
in this and optimize something further. But this will pass, assuming that for this code, it is given in the problem ki n comma k comma w is up to, let's suppose, 100. So if you put 100 in this, 100 into 100 into 100 is 10 to the power 6. We know that in 1 second, 10 to the power 8 will pass. If 100 is 10 to the
In 1 second, 10 to power 8 will pass. So 10 to the power 6 is less than 10 to the power 8. So that's why our code will work.
power 6. We know that in 1 second, 10 to the power 8 will pass. If you put formulas into that, that should be good enough. But w can only take discrete values. But whatever discrete values it is, it will be in the range 0 to w only,
Right.
So that is fine. +1, because what if you don't have any transitions? So I'll give you in one single sentence. This is nothing but this formula that is written is nothing but v plus e. Number of states is number of vertices. Vs into average number of transitions, total number of transitions, that's edges. We are actually doing DAG pay DFS, but I'll not explain that any further. That should be good enough. But
So number of states, like he told, like
this is my complexity. If this will pass, we will code it. If not, then we will not code it. Okay, that means we have to optimize something further. But this will pass, assuming that for this code, it is given in the problem ki n comma k comma w is up to, let's suppose, 100. So if you put 100 in this, 100 into 100 into 100 is 10 to the power 6. We know that in 1 second, 10 to the power 8 will pass discrete values. But what if that is fine? So I'll give you in one single sentence. This is nothing but this formula is that is written is nothing but v plus e. Number of states is number of vertices. Vs into average number of transitions is total number of transitions, that's edges. We are actually doing this. But this formula is that is written is nothing but v plus e. Number of states is number of vertices. Vs into average number of transitions is total number of transitions, that's edges. We are
total number of transition is edges. States is vertices. Total edges is
actually doing Vs into average number of transitions, total number of transitions, that's edges. We are actually doing this formula is that is written is nothing but v plus e. Number of states is number of vertices. Vs into average number of transitions, total number of transitions, that's edges. We are actually doing
N.
DAG पे DFS, but I'll not explain that any further.
Wow.
Just for people who are super interested. ग्राफ नहीं पता तो नहीं समझ पाओगे, इसलिए मैं बता नहीं रहा हूँ. I'm not explaining it. Okay. Okay, this is what we are doing. How do we find average number of transactions? In this case, 2, just take average across all states. यहाँ पर 2 दिख रहा है ना, 2 आयो, this 2 आयो, that's 2. 1 means states will also have a cost. Building those states, initializing them with 0 will have a cost. Yes, also. Okay. So let's say this much is good enough. Take not take other 2 transitions or 2 transitions. How many of you are now 70% clear till this step? What did we do? We thought of the form, take not take वाला format subset. Based on that, we took an idea. I'll be at the item and decide whether to take it or not. Based on restrictions, I put certain things on my parameters, and I return value will be the same thing asked, but only for a sub part of the problem. Yes, there are 2 to the n calls, but we'll come to the code. How does it make it faster? Okay. Then in designing, based on the setup, because once you do the setup 1 and setup 2, this step becomes super clear, right? That once you design this setup, it's obviously 2 choices. So for the 2 choice, write the configuration where you are going. That's natural. Once that is done, you do a simple check quickly. Then you code. Next, I'll teach you the framework to code DP solutions for all problems. Does this make sense to all of you? कि यहाँ तक समझ में आ गया that how to design solutions for this? Next, I'll show you how to design codes for like problems like this. Now, this is in fact done. If you can think for every problem will have the same steps, if you can think it this way, you will be able to get to the final step, and then you will be done. Okay. How do you decide whether to take it or not take it? That code will decide.
उघडे ठेव ना. उघडे ठेव ना. हुई हे देख. मम्मा. है ना? तो पहले नहीं था. देख ना, गोल आ गया ना. हे.
Will not decide. तुम लोग खाते खाते करो डिनर टाइम. कीप ईटिंग. आई लाइक यू डोंट नीड टू वेट फॉर मी. खाते खाते देखो भाई ये कौन से है ना. चलो जी, लेट्स. Average number of transitions means number of possibilities for every I. Over here we had two number of lines that you have over here. Okay. If it gives TLE, then maybe we should look for optimizations. Yes. Yeah, I'll give you homework questions. Don't worry. इसके बाद तो तुम लोग लीड कोड पे आंख लगाओगे. Don't worry. I'll give you, try all the traditional interview questions after this, like coin change. I'll give those as homework. Knapsack, सब बना दोगे. Same चीज. Okay. No, I don't want to go fast. I know that you guys, some of you might know, but for many this should be good learning. So I think this pace is good enough. इससे ज़्यादा स्पीड जाऊंगा तो people will miss. Next code करें थोड़ा बहुत. Let's try to write some pieces of code and understand. Just write number only. Don't write average for now. But it's, if I have to take truly the word, it should be average, because you will later on realize there are problems where the number of transitions each state is not same. It's not take not take for everything. It might be dependent on the number of divisors of certain thing, and you need to take average number of divisors.
मी लावलाय ना 1 तासाचा.
Things like that. I just don't want to be wrong. Okay, let's move to the coding now. So I'll use very simple online GDB, because I know all of you might not have done setup, or I don't know if you have a setup or not. So I'll use online GDB so that you can replicate whatever I'm doing. Just go to onlinegdb.com. Don't run it now, okay? Maybe the site will become slow. Okay, so I'll just quickly set up basic things. I hope if you are attending the DP class, then you know what this headers means, using namespace, std, like this basic stuff, right? So add another restriction, add another state, and I can keep putting in add. Classical. So this is not, I don't think 90% people who know already this problem can also code it correctly. I don't think so, because I've added this simple state, and I can design 5 number of states that if you take the first item, you cannot take the last item. Just add another restriction, add another state, and I can keep putting in add. जो मैं कुछ 3D 2D DP बोलते हैं उससे कुछ फायदा नहीं है. Okay, no need for that. वो सब कुछ नहीं होता. 3D 2D 9D बनाऊंगा मैं अभी. I'll add just 2 more restrictions and it will become 5D. There's no D's and stuff. Okay, this is what we'll do. So do you have a setup? I'll zoom. Clearly visible to all of you?
Yep.
Need 1080p. I think it can be upgraded for free. Folks, for management, let's check. For first week you can upgrade. Once here. Okay, so the way we will take the input is you are given n, the total number of items that you can take, and the number of this you can take, right? The k and k restrictions, the total maximum weight you can take, and number of items you can take.
Yep.
One, मतलब function में कितने parameters उसको लोग बोलते हैं, states बोलते हैं, right? So that's what it's called. So you'll take n, w, k. Now you have a bunch of weights given to you, assuming there are only 100. So I'll take weights of profits of the items. So I items, let's suppose you're given for integer I equal to 0, I less than n, I plus plus. All the items has the given profit and the given P of I and P of W of I. Okay, so the profit of the item and the weight of the item. Okay. So this is what we are taking as an input.
ठीक है.
Next, what will we do? Give me a quick step. Too much line. Give me just one second. I'll quickly fix one. So we took the profits, took the weight, you want. You can define anywhere wherever you want. कितना वीडियो बनाएंगे भाई, कोई दिक्कत नहीं है. चलो let's continue. So we took the profits, took the weights, and we want to design the DP. I just took it global because you can also pass it in function, but I'm easy. Okay. Okay. Let's move into designing the solution. So we will write integer recurrence, which will return us given I how much weight we have taken. The same thing that I wrote over there. Right? If I'm at the ith item, I have taken this much weight, I have taken this much k. What is the maximum profit I can do? This is what I should do. Okay. Next, I'll write three things: pruning, base case, recursion.
प्रूनिंग में मैं बताता हूँ क्या होगा. प्रूनिंग में ऐसा होगा कि जो तुम्हारा अगर वेट टेकन डब्ल्यू के इससे ग्रेटर हो गया तो रिटर्न कर दो, राइट. रिटर्न 0 कर दो, सही है. मैक्स में तो निकल जाएगा. अगर के आई इससे बड़ा होगा तो 0 कर दो. बेस केस क्या होगा, अगर एन आई इज इक्वल्स टू एन हो जाएगा तो रिटर्न कर दो, राइट. रिकर्जन में क्या होगा कि डीपी ये कर दो.
Transition, recursion, return.
रिकर्जन
Okay, this is how you write recurrences. This is how
रिकर्जन के अंदर दो आएंगे कि भैया टेक और नॉट टेक, और रिटर्न के अंदर मैक्सिमम.
you write recurrences. There is no pruning in this problem as such needed, but if wait, we don't need any pruning. Okay, in this case. So we were deciding for 0th item. उसको decide कर लिया, we go to the next item 1, we go to next item and so on. What will be our base case when we are deciding the last item? We are done with that and we will move to the next item. So we will go to state n when we are reaching this. Pruning means if something is trivially not feasible, then you can remove them. Like maybe if W taken is greater than W and stuff, you can write that, but we will never reach there. I'll explain that when we write it. Okay. Pruning means something that is not feasible, you can remove them off in that DP piece of code. So over here, when you are at a particular item, if you decide it, you go to the next item. When you decide this, you go to the next item. So when you are deciding the last item, n minus 1 item, 0, 1, 2 up till n minus 1, you will reach till nth item. Nth पे तो कोई item ही नहीं है, there is nothing to decide. So what can we write? Let me give it over here. I'll move this up, right? This will be better. If I is equal to n, that means we have decided all the previous items. In that case, how much profit can we make from the rest of the item? Return?
कोई नहीं.
0. Perfect. It should be return 0. Why? Because for the rest of the item, there is no profit to be made anymore, isn't it?
है. अगर हमने सारे n ले लिए, 0 से n तक चल गया ना.
If I reach the last item, the definition of this recurrence says if you are n to n तो कोई item ही नहीं बचा है. So maximum sum of profit that you can make from it is 0. Is this part clear first of all? Is this base case making sense to all of you? Quick plus one. We'll do step by step. Okay. So this is top down. This is not bottom. Last index. So the array index is from 0 to n minus 1. So when we reach n, मतलब पीछे से process हो गया. We are at last index. Next we'll design recursion. That integer best, let's suppose is equal to 0. One possibility is either I will not take it. If I don't take it, I will go to I plus 1. Nothing will change. Okay. But if I take it, if I can take it, there is a feasibility check over here also. कि भाई ले तो सकते हैं, पहले check तो कर लो. Taken के लिए there has to be some conditions. There has to be some check कि भाई ले भी सकते हैं, can I take it even can I take it? So if W taken plus the W of the current item is less than equal to capital W and K taken plus 1 is less than equal to capital K, then can I say I can take it? Is this making sense?
Right.
There is so the items are 0 to n minus 1. So at n there is no item. It's 0 indexed. N पे कोई item है 0 1 till up till n minus 1. So this definition I should update to n minus 1.
छोड़ दिया, अगला ले लिया.
Okay.
Right.
Clear till this point? Quick plus 1.
Right.
Wait. Now once I can take it, then one of my possible choices is I'll just update it to answer. One of my possible choices is max of answer. Like if I don't take it, whatever is my choice, max it with. If I take it for this item, I will get P of I plus for the rest of the item, I'll go to this configuration. Same thing that I've written over here. Copy paste the same thing. I plus 1, W of I, K taken plus 1.
Return answer.
कितने लोग यहाँ तक समझ में आ गया? How many of you are clear up to this? Exactly the same. It's free, so I can always not take it. But if we can take it, then that is one of my possibilities. So take max across both the possibilities. This is always possible because नहीं लेना तो कुछ cost नहीं लेना. It's free, so I can always not take it. But if I can take it, then I should try and take a max with that. So this is essentially what we do. So recursion will give me the best possible I can get without taking it and with taking it plus getting the profit of this item. Take the best out of the two. Whichever is the best, return answer.
Yep.
Okay.
Yep.
Easy. And this is something that you can call. You will see out what is the answer. Answer is equal to recursion of 0. I start from the 0th item. I have not taken anything. I have not taken any number of items. Whatever is the best, go and decide. करके ले आओ. That will be my answer.
Right.
This is how you do it. Every single time. Okay.
Yes.
So what is the time complexity of this code?
The complexity is.
No, it might not always be possible. No, it will always try to take this, but it might not be possible if you take too many previously. What is the time complexity of this code? देखते हैं. How many of you have understood it? बताओ भाई जल्दी बताओ.
To the power n. नहीं. To the power n तो वैसे भी है ही ना.
This is 2 to the power n. This is 2 to the power n. Okay. This is not DP. This is brute force. This is recursion. Vivek, आपने तो हमारे साथ धोखा कर दिया. No, no, this is not that. This is just recursion only. This is normal recursion. That for every item you are going on both the sides and you are like just trying everything out. And this is recursion. Okay, pure recursion. It's not a DP. But when you want to make it a DP, you just change this integer DP that there are 100 items. It can take till weight, let's say 1,000, and the number of items you can take is this. You add this DP array. You say that by default I don't know any answer.
Sure.
I don't know any answer. So everything has -1 in the global array. So I made a big array. Okay, and everything has -1. This is a function that sets everything to -1. Okay, and then when I call certain thing, I check if there is a base like cache check that happens. If
Oh,
dp of I, w taken and k taken has already been is not equal to -1 means I have already calculated it. Then return that value.
okay. Shit.
Okay, and
That's
if it
what
is
I
not
was
calculated,
not
then
knowing.
calculate before returning. Save that value over here. Save this value over here and then return. So that next time, if the same configuration is called, it will return it directly from the cache array.
Of course. I'll just take a photo of it.
Okay. So what did we do? Now this is a little like confusing maybe.
Not at all. Take a photo. Pruning, base case, cache check, recursion, return. I can take it and return. Then I'll just write it on my own. पहला pruning की तो जरूरत ही नहीं पड़ेगी. दूसरा base case, तीसरा cache check, चौथा recursion, पांचवा I can take it, और छठा return. इससे easy क्या ही होगा. यही था dynamic programming.
Okay. So what did we do? Now this is a little like confusing maybe. Listen to me very, very carefully. For every item, I'm trying to decide whether to take it or not take it. Just that instead of just calculating and returning, which was nothing but the visualization that we had seen earlier, the Fibonacci visualization,
3 states है तो
where everything was getting recalculated, we said, hey, there will be a big global array which will have value saved, and you can go ahead and complete like check the value whether it has been calculated before or not, and if it has been calculated, then return that value directly from the saved cache, and that, my friends, make it DP. And now the complexity is n into w into k. Yes, you're correct. If there is no default value, then you can make a Boolean array to save things.
before caching of 2 to the power n, and after caching of n into w into k.
Memset, this is a function of C++ which makes arrays filled with values like zeros and -1s. But don't use it with 1, it will not work. If you don't know the reason, Google, it's a very good reason. Okay? Because it works on how does memset works. And things like this is large in HFTs, by the way.
Memset.
Why does memset works with -1 and 0 and not 1? Okay, so this is how you write solution for DP, and this is impactful code of DP.
-1 size of DP.
Memset is a C++ function which makes array. Memsets are distributed DP, no? I'm substituted.
Shit.
Memset has parameter DP. Memset takes the array, the value, and the size of the array. It fills that value with that thing. Right. Thanks for the point. Done with this, understood how did we build the solution code? There is a pruning, which means if something is not feasible, you can write. If w taken is greater than something, if it's not feasible, then you can write it. But in this case, you don't need a pruning, right? But I'm writing it because some problems might need it. You have base case, which is if you reach the last item, you have got 0. If you have cache check, basically, if that value has already been calculated, which means it's not -1 anymore. Because you can always do 0 profit, no? So it can never be -1. So you can just save it and return. Then you compute. If it is not saved, then you compute both the ways and calculate the best possible value. Save it and then return. Cache कुछ नहीं है, right? It's a 3D array. इसमें बस ये parameters pass करेंगे. It's a 3D array. Array. That's it. Why not loop? Because it's just more lines of code. When Memset can do it faster than looping, then why not use it? Not getting why it should return the best possible answer. It's falling sort of greedy only. Because it's the best across whatever feasibility, whatever you can do from the rest. Max of the two options, plus the information that whatever in future also you can do the best is what is written. It's written best, not just any greedily. Okay. What is pruning? What I said? If something is not feasible, if the state is not feasible, then you prune it here so that you don't go into these cases of lines. Right. This is now the typology of this piece of code becomes O of n into k into w. O of k into n into w. Run the code. Chalo, run the code. What is the input? 3 items. Weight was 6. I remember. Number of items was 2. What was the first one? I'm taking profit on this. Let's swap these two. What was the first item? The weight 1. I remember. 3, 5, 2, 2, 4. 2. 4. Let's see. Resistance. Oh. 7 mistakes. Let's do that quickly. 7. How much do we get? 4 plus 3, 7. Screen share hard. Okay. Guys. Yeah. This is how you basically manage this. So I wrote this is the input and 3 this is there. This is how you manage this. Why is it taking -1 if it's already taken? Why is it taking -1 if it's already taken? -1 anyway. Why is it not taking -1? Because you are how many taken till now? You are taking one more. So this is recursive way of implementing it. Okay, and this is in fact pretty much good enough for almost all things. And the power of this is so big that if you actually try and design any more solutions, like I can give you lead code hard problem as well. So this if you have seen knapsack before, you will not see this line. I just added one constraint. I can add n number of constraints. If you take the first item, you cannot take the last item. If you take the first item, you cannot take the last item. If I add a constraint like this, कैसे करोगे? Simply add one more state. Simply add one more state. Have I taken the first item? Yes or not? Based on that, you can maintain. Can I take the last item? Yeah or not? Okay. If I tell you you can only take items such that their weights sum is divisible by something, or I can tell कुछ तो भी restriction में add करूँगा. So all of them will be the same thing.
Yes.
Okay. तो बस यही steps बार-बार follow करने हैं. You have to design the same steps again and again, which is so इसलिए बोलो DP का D is nothing. It's just dimensions जो होते हैं just get decided by the number of restrictions. I can add n number of restrictions. मैं तो वो 90 10 DP ऐसे दिखा सकता हूँ. That doesn't really matter. Okay. So this is something that you guys can now go forward and build on top of it. Okay. Now, which problems to solve after this? Have you heard of problems like coin change problem, knapsack problems? So now, maybe I'll send the links across for these ones. Okay, you guys can try these problems on code and stuff. You'll be able to design solutions super easy. Exact same process, every problem. Sub same. Okay, edit distance is a different form. Okay, you'll try this. Okay.
Okay.
If I becomes greater than n for any reason, let it return infinite, right? Yes. Okay. So now I think we have covered significant for today. Like this will help you solve both the problems that will be there as a quick home task. Knapsack and this. We'll send that across to you all. Try that problem next to design the solution for it from scratch and thinking about it. You can also think of unbounded size. Like what if we have infinite supply? What if we have that every item can be taken multiple number of times? How to handle that? Maybe you'll have an idea like, hey, I am at this item. I can either not take it and go to the next item, and or maybe I'll take it but stay at the same index. So if I just go back to my code, and if I take it and I just remove this, this becomes infinite supply. Every item can be taken infinite number of times.
But how can we move to the next index?
Yes, so just change this and you now can take every item infinite number of times. Why? Because you are saying I'll take this item but I'll stay at I. That's how it works. Okay. Perfect.
Sure.
I think I've almost taught you the framework which people after 50, 100 problems still can't figure out. So you should now be able to build on top of this very, very quickly. Okay. Next is obviously like practicing a little bit. Like there will be more classes and you'll be getting more ideas and stuff. But I hope you guys enjoyed today's session. I think this like going beyond this might be too harsh on you guys for the first day. You'll be saying, but then I hope you guys are you might like the content. Next class, I think there'll be more content covered around DP and you get more practice on things like this, iterative and stuff also will be covered, right? All forms. So some of these forms I've covered on my YouTube channel. Like there was a DP workshop on which I've covered all the DP forms that you guys can check out. Okay. You can parallelly keep learning for multiple sources, no? Right? Sure to clear every source. Yes. Code काम नहीं किया. कहाँ किया ना? 7 आया ना output में क्या बोल रहे हो? Run करो ना code. Output आएगा 7 हमारा. अच्छा तो हमारे पास infinite supply. So 8 आएगा. How it will come 8? I'll take this twice. There are 2 restrictions, 2 item restrictions. I'll take this twice. So it will get 8. Even though the limit of weight has not hit, this will take infinite supply 2 times. So if I have to list all forms, like I'll just quickly give you a brief. Form 1 is this knapsack wall setup, which is items, every item, take, not take. Then there is form 2, which is LIS wall format, where you are building subsequences by jumping over things.
Shit, लिखना तो पड़ेगा भाई. First things first. पहला क्या था? Form 1. Knapsack. Form 2.
Form 3 is nothing but a format where you are building subsequences by jumping over things.
Subsequences by jumping over things. Making subsequences by jumping over things.
Form 3 is nothing but multi-sequence. Matlab, there are 2 sequences and you are solving for parts of this. Edit distance, LCS, all of these are of this class. Form 4 will be nothing but interval dependence. C3 is nothing but uh, multi-sequence. Matlab, there are two sequences and you are solving for parts of this edit distance, LCS, all of these are of this class. Form 4 will be nothing
Distance LCS.
but interval DP or LRDP, where you are solving for an array for a part from L to R. Form 5, which I teach, is essentially game DP. Form 5 will be games. So you are at a configuration. You will go to a winning state or a losing state depending on how you play. Right? That's there. So these are multiple forms, but I think you will learn these over with practice. Don't worry. We'll learn these with over practice. अभी फॉर्म नहीं, अभी हमने आज फॉर्म 1 सीखा. Try solving form 1 problems. You'll get those questions on the channel. Please mention channel. You can search Vivek Gupta Competitive Programming. That should give you. I'll show once. Okay. So I've taught DP once. Let me search for it. I'll send across that on Discord also. I think DP workshop should be fairly helpful. So you guys can watch this one, right? You can search for Vivek Gupta only. And this DP workshop you can watch once. Probably one same question from today one, but this one you guys can watch. This is like day 2, day 3. This is like for form 1. You guys can watch form 2, ending form, LRDP, game DP. These are all rest of the forms. And then building solutions on top of it. And solving at code education, solving CSCS problems. Should be helpful. Okay. I'm the dumb hand advanced वाला तो पढ़ो भाई content नहीं है तो छोड़ दो. ठीक है. Next I think I can take some questions. अब मैं और DP yes for those who want DP workshop का please. Let's have a chat. You can stick with it if you're able to understand everything. But I think for beginners, there's tons of things that you can design around on recursive solutions. It's much better. Like I've been teaching for a long time, but from my experience, I've been able to teach on recursive better because people have been able to design states very easily. Please explain optimal substructure. Optimal substructure क्या था? हमने जो solution बनाया, I W taken K इसका जो maximum है, वो इसके छोटे items having same weights. First में नहीं लेके second में चला गया, second को ले लिया. First को लेके second को नहीं लिया. They can both reach to the same thing. Right? Number of states. Think about this. No restrictions. Think about restrictions. What is restricting you and what to put in the states so that you can design the transitions. That's how you design states. Right? What is state? The parameters you keep in the function of DP is called states. Is there much performance difference between different DP approaches?
मैं पूरे मिनट में आया बस वो बंद कर देती हूँ.
Recursion, much, not much. For some problems, yes, might be because of the reason I told the difference between top down and bottom, but in general, no. So I'm learning some courses and doing this, so will I not do some practice? कर सकते हो. I mean, it's up to you how much time you want to give. Can we do it? Can we give an object twice? Yes, you can loop over a particular item, but I'm taking it k number of times. You can loop over k for integer number equal to 1, number is less than equal to some fixed value 5, number plus plus. You can take it number of times. So in this case, you can put, if you take it number of times, this much weight you are taking and this much number. So number, it will allow you to take this many number of times. So yeah, this is how you design. ऐसी क्लैरिटी रखो भाई, ऐसी क्लैरिटी में क्वेश्चन सॉल्व करता मजा आता है, ये नहीं कि भाई कुछ कुछ करके कोड पास करा दिया. Build clarity like you can solve any problem given to you.
इससे मुझे समझ में आया बिल्ड क्लैरिटी की तुम्हारे चेंजेस से तुम्हें पता चलना चाहिए कि क्या चेंज हो रहा है.
Time also difference.
नॉट कि कुछ कुछ करके चेंज, कुछ कुछ करके बस कुछ कुछ करके कोड चला रहे हो.
Not much. Some optimizations are possible only on iterative, but there are certain problems which recursive code is only possible because all states are not visited. So, but there are exceptions. So, technically no difference. Lead code or code forces, depending on your goal. If you want to get good at CP, then code forces. If you want to get good at intern placement, then lead code. Okay. So, I hope you guys enjoyed this. Can I get 80 LPA placement? 80 LPA technically will only be feasible with very few startup companies at the start, and like next you'll have to go through go to HFTs. ठीक है, उसके लिए अलग restrictions है. SST में जाओ भाई, हाँ भाई. लाओ भाई सीजी लाओ, मतलब मैंने देखा बहुत लोग तो थिंग सीजीपी चाहिए, डेव स्किल्स सीपी स्किल्स लेवल चाहिए. लाओ अगर वैसा है तो जाओ, डिपार्टमेंट भी चाहिए. दैट्स आल्सो restriction to tell you honest. है ना, I've been teaching for like 4 years now. I've seen so many students getting into HFT and stuff. So these two things would be needed, CGPA and good CP skills. कॉलेज भी चाहिए, हाँ मतलब हाँ ट्रू. I've talked with HRs of HFTs like for direct recruitment. So the only restrictions is you'll have to have either top J rank or you have to be in top ITs with certain restrictions. Is your video on computer? No, that's not enough. That's good enough start. Then you'll have to go through the resources I've mentioned in the description. But it's good video. You should watch it first because I think most colleges miss on that one video. HFTs 19 plus चाहिए होता है. HFTs are high-paying companies, high-frequency trading companies. Okay, how much took time to do good in become god in CP? 3 years after 5,000 problems. Obviously, I'm sitting over here because of slides coming courses. Slides क्या video आठ क्या देख लो. If everyone has registered, yes, go to iicpc.com. Then register for this. Font like Chain Street, like Indian companies, Quad High, AlphaGrep, ठीक है, Graviton. These are the companies that you're targeting for. There are many more. Like a lot of students from IT Delhi, Bombay, AGP. मतलब IT
अच्छा ऐसा अगर ये थी क्या, ये तो भाई आई थी हमारे कॉलेज में.
Yeah, I think that has become non-required. CP URL आपका CP URL. If you want a URL, I can give you one URL which you can go through. Linktree. I'll give you my Linktree. It's on the LinkedIn. If you want to also, there is a novice camp that will start from 4th of June. So if you are very new to this, make sure that you how many units you can, but it's difficult because HFTs have many of HFTs in India, like from what I've talked to the HR directly, is 100,000 rank. That's the reality. Okay, but some companies have good chances. I'll be very honest. Yeah. Ah, yes, that's true. Newbie at CF. Yes, so practice career, I think you guys will improve. I'll take some more time, a few more questions maybe. I meant CS, ask companies. I'm unable to solve 4 in lead code and above seeing this. Good amount of practice. We need to know all standard ideas of all topics. Then we'll be able to go. So, next classes will be from different speakers. I just thought, yeah, let's take one session for you all, and I hope you guys enjoyed it. But I think multiple speakers will take multiple sessions, and they're also designing it really well. So I hope you guys enjoy those sessions too. Go see. Also, pushing it. Prepare for launches. कोच का प्रोसेस इस रेटिंग लॉस होने का फियर को कैसे काउंटर करें रेटिंग लॉस होने का फियर कैसे काउंटर करें दो आइडिया देखो एक अच्छा एक अच्छा टेक्निक है कि यार थोड़ा समझो कि रेटिंग अगर मैं आज आई कैन मेक अकाउंट एंड गेट रेटिंग इन 4-5 कॉन्टेस्ट बाय 2100 this means rating also participate. I tell about topics from newbie to people. Mostly you have to improve on greedy, constructive goods. The lesser you grow. That's my philosophy. I have taught so much from newbie to people. Mostly you have to improve on greedy, constructive implementation a lot. That's something you should improve on. Okay, is bringing code videos back because actually first trying to solve these problems. The more you see codes, the lesser you grow. That's my philosophy. I have taught so many students as of now. Maybe you'll believe me now or maybe you'll believe with experience. But the more videos you see in which the solution code has been shown and then you go and solve this problem, which is practically the problem with every sheet in this world, the lesser you grow. This is my philosophy from teaching so many students. I've tried and tested it multiple times. It works. The lesser codes you see, the more code you try to write on your own, the more you grow. So see less codes. Try. You can see hints, you can see editorial English, but don't see codes. Just follow this philosophy. You will grow 2x faster than most other people on average. Because मेरे पास हजारों लोग आते हैं जो बोलते हैं मैंने शीट देख के पूरा सॉल्व कर लिया बट मैं ग्रो नहीं किया. क्यों नहीं ग्रो किया? क्योंकि मैंने वीडियो में सारे कोड देख लिए फिर वही टाइप कर दिया. और अभी मेरे से नए क्वेश्चन कोड नहीं होते. Learn from editorials. Yes. Yes, imperatives. करो भाई अच्छे से practice करो. Graph DP strong कर लो यार बहुत ज़्यादा. Be super strong at graph and DP. My friends with Shaitan, I haven't met him. Do revision required to be good at solve plus. How do you revise? I generally maintain a sheet of problems that I've solved earlier and then go through them mostly. But whatever I've solved is. Why is there so much crowd on this small channel? Because they are doing a really good job by helping people to get into CP. That's why there's so much crowd and there are people who are interested. See if different districts 4 तक कितना topics है. DP graph तक पहुंचना पड़ेगा. But third तक पहुंच like 14 तक पहुंचने के लिए I think you can do without DP and graph, but after that you have to learn. Specialist to expert, I think design factor becomes DP and graph. उसके बाद तो कभी constructive होगा कभी नहीं होगा, but you have to get really good at DP graph and also maths obviously. Code forces में maths is inevitable. How often need to revise things? It depends person to person, but I think whenever you find next instance where you forgot something, revise them. When CF rating is good enough to clear most OAs, 1600 plus should be good help. 1900 plus you'll be able to almost crack almost all OAs. Maybe 1-2 left, except HFTs, 1-2 companies. Some companies are still harder for 1900s, but in most companies, this is what TN graphs. I don't have any resource at this point in time. Google. How to improve maths using CP? Do read more proofs. I think that's how we'll improve. Bit manipulation. I taught one technique today on the channel. देखो वीडियो आजकल लीड कोड का 4 प्रॉब्लम देख लो जो मैंने डिस्कस किया आज. But comfortably lead code problem not able to perform at lead code forces because of ad hoc and maths most probably. तो मैं भाई बहुत please share it with my videos. Yeah, I'll share it in the Discord later on. Okay. It's on the mang.in website. The more you practice, the more better you're going to become. What's the DP workshop? What's the next classes that will happen on the camp? You guys will be able to grow very, very fast. Okay. So best of luck for the camp. Keep learning, and I hope you guys grow a lot. On my LinkedIn, you can send me a quick connection request. I'll accept if you just mention I was in the live session. Okay. This is for anybody who's watching it. If you mention that, I'll accept it. यानी क्या तो Instagram पे भेज रहे हैं message because link पे सब है. Please don't accept it. Okay. Mention कि I was in the live class क्योंकि 7,000 pending messages. I cannot possibly accept more. Okay. Cool. चलो then. Thanks for joining in, guys. We'll meet up in the next class again. See you all in the next one. Bye.
ओके, अरे हो 2 घंटे का वर्कशॉप है.